Today we are going to see the degradation pathway and salvage pathway of the purines. Here we have the GMP, and here is the AMP, and we know that this is adenine because here that is the sixth position, because this is the first, the second, the third, the fourth, the fifth, and the sixth position. Here is a amino group, and here is a ceto. So because here is the amino group, this is adenine, and so this is AMP, and this is GMP. The enzyme nucleotidase takes away the phosphate, and so now we have nucleosides, and now this is guanosine, and this is adenosine. Then the adenosine is converted into inosine by the adenosine deaminase, who takes away this amino group, which takes away that amino group and put a oxygen, and so now this is inosine. Then the nucleosidase takes away the ribose, and so now this is guanine, and this is hypoxanthine. And then now here are two pathways. These molecules can go to the degradation pathway or to the salvage pathway. If they go to the degradation pathway, the guanine is converted into xanthine by the guanine deaminase, which takes away this amino group and puts a hydroxyl group. And the xanthine oxidase puts a hydroxyl group here in the second position, because this is the first position, so this is the second position. And so now we have two xanthines, and then the same enzyme that puts this hydroxyl group, the xanthine oxidase, now puts a hydroxyl group here, and so now we have the uric acid or the urate. And when we have the guanine and hypoxanthine, the other pathway that they can go is that the hypoxanthine, guanine hypoxanthine phosphoribosyl transferase can take the guanine and takes 5-phosphoribosyl 1-pyrophosphate, and so converts the guanine in GMP, and takes or can take hypoxanthine and 5-phosphoribosyl 1-pyrophosphate and converts this into IMP. And so now we have IMP, and then the IMP can be converted into the adenosine with the aspartate, the amino group that is in the sixth position. Yes, that is in the sixth position is from the aspartate, and so like that we would have the AMP. And when this enzyme is deficient, so we can't save these purines, and so the only pathway to which these molecules can go is to the degradation pathway that ends in the uric acid, and so there is very much uric acid, and there is then the gout that is produced by the accumulation of that uric acid, and they continue to produce the purines because they can't salvage them, and those patients begin to eat their lips and their fingers, and that is Lesch-Nyhan syndrome. And the other pathway in the salvage pathway is that we can take a adenine free of the cytoplasm, and with 5 phosphoribosyl 1 pyrophosphate, it is converted into AMP and pyrophosphate. We see you in the next metabolic pathway.